Now in this problem, we have a transistor switch. Okay, so we want to determine the saturation current for the transistor in this figure, and the value of the base current necessary to produce saturation, and finally the minimum value of in the input voltage necessary for saturation. So the equation for the saturation current is given by VCC minus VCE saturation divided by RC. Okay, so in this case, we don't have this VCE saturation current. If you recall, if we have the IC versus VCE curve, the family of curves rises like this and then sort of flattens out like that and then goes up. So the saturation, VCE saturation, is this point here. Okay, but in this case, the value is not given, so we just set it to 0. So in this case, VCC is 5 volts, and we divide it by the collector current, which is 10 kilo ohms. So IC saturation is equal to 0.5 milliamperes. The next is to find the base current. Okay, and we know that the base current is related to the IC saturation current through the DC beta parameter. So IC saturation is 0.5 milliamperes. Our DC beta parameter is 150. So this gives us 3.33 microamperes. Now to get the minimum voltage, input voltage, to turn on the switch, or to push the transistor to saturation. So we first need to subtract this voltage across this current, this base resistance here, and then also the this voltage across the base emitter, and that's our V in. Okay, what I mean is V in is nothing but the base current that we have already solved times RB, and the VBE. Okay, so this is the input voltage, okay, with respect to ground. So that's 3.33 microamperes times 100 kilo ohms plus VBE of 0.7 volts. Okay, so this gives us a minimum input voltage of 1.03 volts. Okay.